In 1832, Faraday said, "If you have magnetism and motion, you will get electricity." It was the beginning of power generation. Today, the modern brushless alternator is highly efficient and reliable under the most extreme operating conditions. Petbow build them for their range of diesel generators in service all over the world. At their factory in Sandwich, Kent, they've built around 18,000 generators in 20 years. Their alternator plant is one of the most advanced of its kind. Raw materials of the highest quality come in one end and completed alternators go out. First, a shaft is machined from high-grade steel. It carries the laminated main rotor with its field coils and damper windings. It also carries the exciter rotor. Connected to the exciter is a rotating rectifier which completes the rotor assembly. The outer frame is fabricated from steel plate reinforced with steel bar ribs, which retain the laminations and support the main stator windings. The stator is now ready for the rotor to be inserted. For the alternator to operate efficiently, the air gap between the stator and rotor windings has to be exactly correct. The end of the shaft is fitted with self-aligning roller bearings, packed with grease and sealed for long life. The end cover supports the bearing housing and the exciter stator, with its own field windings and built-in permanent magnets. At the other end, the fan is fitted to the shaft and the coupling chamber to the frame. The last component on the shaft is the flexible coupling disc, which will bolt directly to the engine flywheel. A terminal box welded to the stator frame contains the output terminals, circuit breaker and automatic voltage regulator. The familiar shape of a generator is now emerging. A control module added to the top and a diesel engine complete a Petbow power center. At the heart of every alternator are the laminations. They carry the windings on both the rotor and the stator. This is where the manufacturing process begins. The laminations are made from thin insulated steel of a very high grade. They're mass-produced on an automatic blanking press. Then on to the notching press, where the characteristic alternator slots are punched in, leaving the separate inner rotor and outer stator laminations. Petbow themselves fabricate all the steel sections needed for every alternator. This machine automatically follows a drawn template to produce the various shapes required. A steel shaft is machined to a high degree of accuracy. It will carry the rotor assembly. The laminations are added and held between end plates. After compression, they're welded up to produce a solid core assembly. Laminations are also built up inside the bore of the stator frame. They too are hydraulically compressed and welded up, ready for the stator windings to be added. The output windings of the alternator consist of copper wire. The standard of insulation is very important. Petbow used Class F materials throughout. The laminated rotor assembly is wound with high-grade wire under constant tension to produce really solid windings, able to withstand the severe centrifugal forces which occur in operation. The number of turns in any one coil is predetermined by the electrical output required. After winding, the 4 coils are connected together before passing to the next stage of fitting the copper damping bars. They are pushed right through the leading edge of each pole, and a circular copper ring is brazed into position at each end to interconnect all the bars. Treatment to make double sure of their alternator's continuous performance in severe climates all over the world. The exciter rotor is built individually before being fitted to the main rotor shaft. The face of the rotor is turned to the diameter that will give the required finished air gap between rotor and stator. Another sub-assembly fitted to the main rotor is the rotating rectifier, constructed from aluminium heat sinks. It carries 6 high-quality diodes and is fitted with a field suppression device. Inspection is carried out at every stage of manufacture. The completed rotor assembly is balanced to a high degree of accuracy. While it spins, out-of-balance forces are detected and corrective balance weights are added. The stator frame supports the terminal box which will house the control equipment. Now the final assembly. Positioning the rotor inside the stator is carried out with considerable care. The bearings are preheated before being fitted to the end of the rotor shaft. They run in sealed housings, pre-packed with grease for a long operational life. They are also self-aligning. The end shield carries the exciter stator and the bearing housing. Next, the automatic voltage regulator is fitted. Petbow have put a great deal of research and development into their solid-state AVR, which is manufactured in their own electronics division using flow soldering techniques. It's a plug-in type and operates on a safe low voltage, which allows checking without stopping the set. Electrical testing has always been an important feature of Petbow products. Here, on production test beds, every brushless alternator is coupled to a driving motor and thoroughly tested. The electrical output characteristics are checked against standard data taken from comprehensive testing on prototype and early production machines. So how does a Petbow brushless alternator generate electricity? The exciter stator contains permanent magnets which produce a permanent magnetic field. As the rotor begins to turn, windings in the exciter cut through this magnetic field to create an alternating current between the exciter rotor and the rotating rectifier. This converts the current to DC, which flows to the main rotor windings along cables in the center of the shaft, creating another magnetic field between the main rotor and stator windings. Magnetic flux from the rotating field is transferred to the stator windings to produce an AC output. This output is sensed and measured by the automatic voltage regulator. This draws DC via a rectifier from a separate winding in the main stator. It feeds the DC to windings in the exciter stator, which take over from the permanent magnets. This builds up extra magnetic flux, which creates more current flow, in turn producing more flux, and more output. As the speed of the rotor increases, there's a rapid and positive increase in power. When the correct voltage is reached, the AVR keeps it constant by sensing the output voltage and load variations and controlling the supply to the exciter stator. In Petbow's power center assembly shop, the alternator is fitted to a diesel engine to form a complete generating set. There's a range of sets from 20 kilowatts to 5 megawatts, with a wide choice of engines and builds. There's also a choice of control boxes that hold interchangeable plug-in circuits for control and alarm systems. Before it leaves the factory, every set gets a final test. Because Petbow make the alternators that go into their generating sets instead of buying them, they can control the quality of workmanship and finish. Their exceptional reliability and performance has been well proven over the last 20 years throughout the world. And Petbow build in many extra features. There are permanent magnets in the exciter poles. This means a very fast voltage build-up when they start, even with the load connected. They're able to start up larger electric motors than would be normally expected. They will cope with short-circuit fault conditions without damage and rapidly recover voltage after sudden heavy load changes. They accept 100% out-of-balance loading and still retain a good voltage regulation, something few other machines are able to claim. Synchronizing 2 or more generating sets together is easier and smoother with Petbow alternators. The special quadrature voltage loop circuit incorporated provides exceptional tolerance during paralleling. These are just a few of the special features that Petbow include in their alternators. They put a lot in, and their customers get a lot of performance out.